Alright guys, welcome to another Create of the Week video. And in today's video, we're going to take a look at Mockall. And Mockall is a framework for doing mocking in unit testing in Rust. Now, before we get started, if you are looking for some content on Rust and TypeScript, make sure you take a look at my Udemy page. I'm going to provide a link in the description. So let's get started. Now, as I mentioned in my first video in this series, the way I want to do these overviews is I want to make them more realistic. So in other words, instead of having that crate kind of in isolation, I want to put it into a context where it's most likely to be used. So one of those contexts would be accessing a database and mocking those accesses in a unit testing scenario. So what I've gone ahead and done, and this project will be available in the description. So what I've gone ahead and done is created a project that has a Docker image of a Postgres database, and you can deploy it using this script file. The instructions are in the README. And the database schema is represented in this migration file. We're using SQLX, by the way. And if you decide to go into the project and kind of maybe try out some of these testing scenarios for yourself, you will be able to find all the entities listed out in this one SQL file. But the main one that we will be focusing on in this project will be the profile table type. So the first thing that we're going to do is we're going to look at the automated mocking mechanism that is in Mockall. There's basically two main feature sets that you can use inside of Mockall. One is a highly automated version where Mockall basically creates the mock on your behalf, so you can eliminate a lot of the boilerplate. However, there are certain mocking situations where you want to get in and manually do it yourself, either because you need to customize or because the trait interfaces are not available to you. They're in some external crate. So we'll look at both of those scenarios, but we'll start with the auto mocking. Now, the reason why this file looks like this is I did want to save some time in terms of some of the boilerplate stuff, like the imports and whatever, but also I wanted to create this connection pool function ahead of time, which obviously is returning the connection itself. Because the first example that I want to give is actually making live connections to the database so we can compare and contrast the activity of making a real connection and then how Mockall kind of comes in there and does the mocking pieces for us. So the first thing that we have to do in order to utilize Mockall is we need to structure our project so that it's driven by interfaces, which obviously in Rust is called traits, right? Because Rust is a truly statically typed language. So if we want to have different implementations of our structures, so the real implementation and then again the mocked implementation, then we need to drive everything off of traits, right? So this trait is going to be asynchronous, so we need that. And then we are going to be getting stuff, in this case a profile. So we'll pass in the object itself, and I'll show you in a moment why we need that. And then we need the ID of the profile. And in this case, this request by this ID may fail and we get back nothing. So that's why this is an optional. And then if it is successful, I want to return a profile object. And this is also something that I've gone ahead again to save time and not bother showing you a bunch of boilerplate and stuff like that. So this is set up ready to go for SQLX as well as some of the other types that we will be using. So we have that. and then the entire call could fail. So we also may return an error. And then if we are getting back a profile object, then we will also need to create one. So that's why we have this function. And these types I just showed you in the models file. Okay, so our code, again, is going to be driven by this trait, by this interface. And then, as I said, in order to make this a more realistic example, I'm going to make initially real calls, like actual calls to the database. So in order to do that, we need to implement the trait functions that we have here. So let's just copy and paste that, and then we'll get that in there. So in order to make a typed query in SQLX, we go to SQLX, we get that specific type of querying function. Then we need to pass the database type, which right now we don't really care about. So I will ignore that. And then we define the actual query that we want to make. So in this case, we're doing a get. So I'm going to do a select all the fields from the profile entity table. And then it's based on the ID, which is set to the first parameter. And then again, in this case, nothing might come back because an erroneous ID was given. So we use fetch optional to indicate that, some or none could come back. And then here, we need the actual connection itself. So we provide that, and then we await on the call itself. So then next, we need to actually be able to insert something. So we're pretty much doing the same thing, except the query is of course going to be different. So we're going to insert into table profile, and we're going to do the username, the full name, the description, the region, the main URL, and then the avatar. So here we will have 6 different parameters. And then we are getting back the ID, which is why we needed this type. So I'm going to try and save a little time here. So the full name, the description, the region, the main URL, and the avatar. So this time we are doing fetch 1 because unless there's an error, we should be able to get something back. And then we also have to wait on this as well. Okay, now we've set up the core items, right? We have the interface, the trait itself. It's going to be implemented in whichever way we desire. We might have multiple implementations for production and development or otherwise, but we also have the mocks that we're going to be using for our testing, right? Now, in order to make use of this, we need to have some sort of mechanism to actually inject the appropriate implementation at the appropriate time, right? So we're going to have a container structure. Okay, so this container structure is going to have any type as long as the bounds are that it implements the repository trait, right? So that therefore we leave it open-ended where we could use this implementation, right? The production implementation, but we could also swap it out for a mocked implementation or a different production implementation, right? So then I'm just going to create the new function. So let's just expose these. So now we're able to instantiate an object based on DB service, and it will be passed some implementation of our repository trait type, and we'll be able to make use of it either in production or in our tests. So then if we go to our test section, then let's define a new test. So this will be an asynchronous test. So let's just give it a simple name. So here we need our actual implementation. Okay, so we have our service. It's the real service, and we're going to go ahead and make calls on it. So the first thing we need to do is actually create a profile. So let's just use this. I'm going to put the first username in here. So what we're going to use is Faker. So Faker allows us to just automatically generate a bunch of fake names and fake entries for some of our tests. So in this case, we're going to use the username. And it's going to be of type string. So then we have our full name. Let's just set all of these up right now. So this one, I'll just hard code some fake entry in here. So this is going to be a binary file. So we'll just create an empty for this guy. All right, so we have some prerequisite parameters for our new profile object. So we go in here, we get rid of all of this. So let's grab that result, right? So it's the entity ID. And then let's query back this object to make sure that it actually came back. So we want to unwrap twice because it could not only fail, but it could also be optional. So now we have the actual profile object. And let's do an assert on it. So I'm going to compare the IDs of the inserted to the queried. So we clear that. All right, so we can see that data is being inserted and data is coming back, and we can actually make real requests to our database, and it functionally works, right? So now we want to actually write real unit tests, right? So mocked unit tests where we're avoiding the actual call to the database because obviously it's much slower and you could have failures because of some networking issue or the database is down or whatever, right? So how do we do that? Well, the first thing that we do is we use AutoMock in order to tell Mockall that this trait is something that we want to have it automatically mocked for us, right? So in other words, create the structures that will represent a mocked version of our database repository, right? So then we can leave all the other real implementation code alone because obviously we would still want to use that. And what we do is we get rid of all of this, right? And then we get an instance of our mock. So now, because we used AutoMock, Mockall has gone in and through the macro system, it has created this special struct type, right? So we can create a new instance of this mocked struct type, and we have to make it mutable because every time we set it up, we're actually modifying the structure of it. So then if I take it, I have to now indicate how I want to do the mock, right? Because obviously situationally things are different. So one of the things that I can select is the function call that itself specifically that I want to mock for. And then I can also determine things like they're called expectations within the Mockall system. But basically, I can check as my function gets called. In this case, will certain parameters that I want to be used, that I want to make sure get used, are they actually being passed into the function, right? So in this case, we have, other than the self object itself, we only had one other parameter, which was the ID. So I want to make sure that that parameter, the ID, is passed in as a value of 1. And then this predicate is going to make sure that that is the case, right? So then the other thing that I can do is I can determine the number of times that this function was called. So in this case, I put ×1, which means specifically that this function should only be called one time. And if it is either not called at all or called more than one time, then we should get some sort of panic. And then finally, we have various ways of returning specific values that we want. So in this case, we are trying to query for a profile object, and it's potentially optional. So we need to wrap it like this, and then we can return a hard-coded profile object that we define. But in this case, I don't want to type all of these all over again. So I'm just going to try and reuse these. Now this I can just hard code as 1. So I'm just going to go in and pass all of these in here. let's make these easier to read. All right, so now we have our mock set up. Again, there's various ways that we can do the setup, but we've set it up for these expectations that you can see on the screen right now. And then what we do is we pass the mock into our DB service because, again, as long as the bounds match the repository trait, then everything still works, right? So then if we come back here and we try to make a call to the actual service call itself. So again, I'm going to put in 1. So then if this is successful, then our assert should be, the profile ID should be 1, since that is what we are expecting to happen, right? To be returned back. Now in this case, just to show you as an example, I'm going to deliberately put in the wrong parameter value. So in other words, this will not match up. And then let's see what happens. Okay, so as expected, our call has failed. And then it can show you right here where the failure occurred. Now, I don't love this message. It's kind of like, it's not that descriptive. I would say some of the other messages that we'll see are a little bit better than this, but nevertheless, you can see the incorrect parameter that is has been put in there, and then the expectation that failed, right? So then if we go back in here and we put that back to 1, we have a passing test, right? Okay, so pretty simple setup, right? We got at least one of our expectations to run as expected, right? Now, again, I'm going to show you, just to kind of complete this, I'm going to show you the effect of the times expectation test, right? So we expected only 1 call to be made. And then, we made 2. So you can see here, right? Called 2 times, which is more than the expected 1. Okay. All right. So then this is pretty cool. It's quite easy, as you saw, to both understand and also to actually work out, because there isn't really much in terms of boilerplate that we had to add in. But there is a question. So we have here a simple scenario where we're checking not only one parameter, but we're checking this primitive type, right? This equality check predicate requires a implementation of partial equal, right? So this is a problem, because if we happen to be using an external type, which is in this case PG pool, which I'll show you in a moment, it wouldn't work, because in the case of PG pool is external and it is not implementing partial EQ. And of course, there's other scenarios where partial EQ is not implemented, and therefore we can't use this type of mechanism to test the incoming parameters. So there is another function available, And this function is giving us the ability to insert a closure instead, and then check a customized check for a customized Boolean value. In other words, we ourselves are implementing the logic of what is valid parameters for our particular situation. So if I give an example of that, let's say, for example, the function itself was, the get profile function itself was modified so that it takes two parameters. So it takes the ID that we were already passing in, and by the way, these have to be references, but it takes in the ID, but it also takes in the connection pool itself as a parameter, right? So then in that case, we would need to use the with F in order to customize the Boolean check, expectation check ourselves, so that it only checks what we wanted to check in the way that we want to have it be checked. So in this case, really the only thing we cared about is that the ID value was given in was equal to 1. So that's what I've gone ahead and done right here. And then if you see this, obviously we have to now modify the implementation of the trait, right? Or the definition of the trait. So if we go in here, and we go ahead and do that, so now I've gotten rid of the member pool from DB repo. So I need to get rid of these. Okay, so now the connection pool is coming in as a parameter, and that's what we defined our mock to expect, again, our expectation. And then that means that we would need to pass in that connection. So I'm just going to stick it directly into the parameter, and so everything is still 1. All right, so let's check that out. So whatever we do in that place, we need to also do here. So we're not going to actually use this either. So that should be it. Okay, and then the test passes, as you can see here. Now, so this I find to be like really awesome, because the amount of, because, you know, Rust is such a verbose language, right? There's so many, like even this simple thing, right? You know, there's so many colons, and if you're using generics, then you have all of this stuff that you have to write. It's a very busy language. So any kind of tooling that helps you reduce the number of lines of code is always a big deal to me. Now, as the name implies for this project file, we've called it auto, right? So the automated way, or the automated mechanism for doing some of this stuff, right? Now, what if we have a situation where the trait that we want to make use of and the implementation that we want to test is in an external crate that we don't have access to, and obviously then we can't put AutoMock in there, right? So what do we do in that scenario? Or if we want to have a specific set of implementations where just we implement one of 20 different functions, right? So in that scenario, now I'm just going to comment these out so we don't get any errors. All right, so in that scenario, we can do a custom or manual mock. So the way that works is there is a macro called mock. And inside of this macro, we define the structures that will represent a mocked implementation of whatever trait it is that we are trying to mock. So that doesn't really clarify anything. So let me just write it out for you. Now again, to save time, I'm just going to copy and paste these. This is only because I'm missing this. So what did we do here? So what's going on here is, obviously, even though this is an impl, there's no actual implementation here, right? So what we're doing is we're just creating a skeleton structure, again, because we're pretending that we don't have access to this trait in terms of being able to modify it and put in whatever, derivation macros that we want on it. So we are using this macro mechanism that Mockall provides in order to help to provide hints, basically, to Mockall, so that it can internally create a struct that has a fake implementation of this repository trait. Now, the other reason why we know that something like this is happening is because this is obviously not Rust syntax, right? This isn't, for example, this isn't this, right? So all this is just, I don't know if I would call it a DSL, but basically it's Mockall's own syntax where we create a label or a sub-label that we're telling Mockall, hey, Mockall, I want you to ultimately create a mocked structure whose name will be based on this name, and which will have these fake implementations and expectations, right? So by using mock, we're not defining this huge implementation. We're still freed from doing that much boilerplate code, but at the same time, we still need to give these hints to Mockall so that it can still create that final mocked structure. So what that looks like is this guy right here. So you can see the partial name that we had put up, my repo. So this guy right here. So then in creating the actual struct that we use that represents our mock object itself, it bases it on those hints that we provided within the mock macro, right? So then the rest of the code is basically what we already did, right? So we're still using this secondary syntax where we added the pool connection. We're still only checking for one call. We're hard coding the values, et cetera, right? So we have this mock now, and the rest of it is basically the same thing. So if I run this, the reason why we get 2 is because although this test isn't doing anything technically, it's still a test. So that's why we have 2 items there. So that was the end of the video. As usual, please like, subscribe, and I'll see you guys next time.